So welcome to chapter 4. Now, 4, we're going to talk about memory. Now, the memory that's inside of our computers, it's not infallible. You can have electrical hiccups. There could be memory that is not seated properly, or there just might be connections for the memory that's inside of your system, and occasionally there might be a bit that accidentally gets flipped from a 1 to a 0, or vice versa. These things happen, and it's just all it is an electric charge, and sometimes they get flipped around. If you have a critical computer system, however, you really can't afford to have memory that might be changing some of the values as it's going through the computer, regardless of how rare that might be. So your virtual machines, you might have database servers or web servers or systems that are required to be up and running all the time. Now, we don't want these systems to fail, so we need to try to have this consistency. But these things do happen, and we need to recognize what the problems are. And because of that, we have a type of memory that's able to check itself. One of these types is called parity memory, where it adds an additional parity bit to the information that's associated with a byte that's going through your computer. A parity memory is great, but it won't find every possible scenario. For example, if your memory becomes corrupted in a way that the parity is still correct, then it's not going to notice that there's anything wrong, and it's going to keep going about what it's doing, as if no problem exists. And the parity memory is not designed to actually correct anything. It can only inform you that a problem exists. Now, a type of memory that's able to make a correction is called error correcting code memory, or ECC memory. That's not only identifying that there has been an error within the memory of your computer, but it's also able to correct that memory on the fly. Now, not all your computers are using ECC memory. In fact, very few computers are actually using ECC memory. The ECC's memory bit, it's more expensive, and it's really designed for those enterprise type systems. So a very large server may have a motherboard that requires ECC. In fact, it won't work unless you install ECC memory into that device. So that system actually requires ECC memory. It's sometimes difficult to tell, though, because the memory, it looks identical to non-ECC memory, so you've got to make sure of what type of memory that you're dealing with. Right. Now, sometimes you can identify stuff visually when you're using a registered memory because there may be additional chips. Sometimes we can look at the number of pins that are on the stick of memory. Sometimes the system itself will say, if once we've seated it, what memory we have. Traditionally, we'll have some label that will identify our memory. Now, one characteristic of memory is whether it is single-sided or double-sided memory. And there are, unfortunately, a couple of ways that this can be interpreted. One is, it's literally, you can have a memory module that only has chips on one side of the module and no chips on the other side of the module. So in that case, it'd be a single-sided memory module. But some memory modules will have memory chips on both sides of the physical module, and some people will still refer to them as double-sided memory, and some may say single. There's another way to interpret single-sided versus double-sided memory that really doesn't describe the physical package of the memory. And this is why I said before, they may look at it and see that there's chips on both sides, but not call it that. In this case, we're really referring to the ranks of the memory. Ranks is how we separate memory on a single module so that they can be accessed with the memory controller. Now, sometimes these separate ranks are called sides. So you might have a single-sided or double-sided memory referring to a single rank or a double rank on a memory. These would really be separated into two different pieces. This, for instance, might be a memory module with two ranks, or you could have easily described the same thing as two sides. So if you're looking to upgrade to the memory that's inside your computer or install some onto a new computer build, now you can go online and see what's available. And then you can very quickly see that there are many types and many kinds of specifications. A memory has a very tight tolerance. You don't want to exceed the expectations of the system or the requirements of the system. You need exactly the right memory for your motherboard. So your first stop should be the motherboard documentation. This will be the absolute authority to determine the type of memory you need to be able to purchase for your motherboard. Okay. Now, in going through the videos and going through the slides, you'll see that we've got traditionally 4 slots for memory. We'll have DIMM slots. We can have DDR3, DDR4. We've got the different speeds. And we have to know exactly what the expectation is for that memory. Okay. So I'll see you in the next video, and keep up the hard work.